Hi, good evening everyone. Today we are going to discuss about the hydraulic calculations based on NFPA 13. So what is hydraulics and hydraulics calculations? Hydraulics is a branch of fluid mechanics, deals with the mechanical properties of liquid. In the context here, it is the water. So why are we doing the hydraulic calculations for the sprinkler system? In order to estimate the water demand required for the building, to validate the pipe sizes proposed for the distribution network because of the velocity and the friction loss, to analyze the pressure required to select the fire pump, and also to identify the pressure at different junctions of the network, to select the pressure rating of the pipes and fittings, as well as the requirements of a pressure reducing valve where the system pressures exceeding 175 psi, because NFPA 13 mandates to install a pressure reducing valve when the pressure increases to 175 psi. And also to check the water adequacy for the building if it is supplied by the fire main. We have several softwares like Elite Fire. There is a methodology to determine how much water is required for this building, or based on the available water flow, is the sprinkler network designed will be functional or not. So there are two types of calculations mentioned in NFPA 13 to evaluate the water demand. The first is the pipe schedule method, and the second is the hydraulically calculated method. The pipe schedule method was invented at the first, then the hydraulic calculation method was invented in late 1970s. The pipe schedule method is a straightforward exercise. There are some tables provided in NFPA 13. We have to follow the tables regarding the flow rates, and there are some tables provided in NFPA 13 with regards to the pipe size based on the number of sprinklers. Whereas the hydraulic calculated method will be using a density area chart. The main difference between the pipe schedule method and the hydraulically calculated method is pipe schedule method is assuming that your entire building has no fire barriers and the fire originated at one point can be spread to another portion of the building. So the water demand needs to be sized for that reason. Whereas the concept of hydraulically calculated method as per NFPA 13 is based on a fire happening in a single fire area, and it is confined within the area of origin by having fire barriers. Because the NFPA codes were evolved a lot from 1970s, the introduction of NFPA 101, which introduces the barriers. So they have applied the concept here for hydraulically calculated method. So before we go into pipe schedule method of calculation or hydraulically calculated method of calculation, we should understand the hazard classifications as mentioned in NFPA 13. So if you look into NFPA 13, Chapter 5, 2019 edition, you can see the hazard classifications. NFPA 13 defines 5 different types of hazard classifications. Light hazard, ordinary hazard 1, ordinary hazard 2, extra hazard 1, extra hazard 2. These classifications are given based on the amount of combustible materials present in a typical building. So light hazard is the less combustible building, whereas it goes further to extra hazard, the combustibles are getting more and more and more. There is some examples are given in NFPA 13, Chapter 5, which include certain kind of occupancies which are listed as a light hazard occupancies. And if you have certain kind of building which is very similar to the buildings which is mentioned here, you can use the light hazard configuration. Same goes for ordinary hazard group 1, group 2, extra hazard group 1 and group 2. So if you see the examples, the light hazard, residential buildings, restaurant seating areas, nursing homes, institutional means which is the prisons, educational facilities, ordinary hazard group 2, or automobile parking and showrooms. But remember, the latest NFPA 13 edition classifies the automobile parking garages into ordinary hazard group 2. So there is an example given for extra hazard group 1 as well and extra hazard group 2 as well here. So you can go through this and you can determine what kind of hazard you want to design the sprinkler systems, because the hazard classification is most important, since the density of the water required for each hazard is different as per density area chart. If you are designing in pipe schedule method, the flow rate for each hazard varies. So the hazard classification is most important part in hydraulic calculations or to design a sprinkler system, because the spacing between the sprinklers will be varying based on the hazard classification. So the step one methodology is to identify what is the hazard classification of the building under design. Okay, before we proceed into the hydraulic calculation procedures, we need to understand a basic formula given in NFPA 13 under design approaches, how to calculate a flow rate from a single sprinkler. The flow rate calculation is Q is equal to K square root of P. Here the Q is flow rate, K is the K factor of the sprinkler, and the P is the residual pressure coming out of the sprinkler. So the normal half inch standard response sprinkler will be having a K factor of 5.6, and the minimum residual pressure as mentioned in NFPA 13 is 0.5 bar, which is 7 psi. So if you multiply this, you will have a result of 14.9 GPM. If you want the result in LPM, liters per minute, the K value you have to take in metric, 5.6 will be equal to 80, and the P value, which is the pressure, you should be adding in a bar. So you will be getting the result as liters per minute. And also remember, NFPA 13 specifies as the minimum pressure required for a sprinkler, which is the residual pressure coming out of the sprinkler, is 0.7 bar in order to create a proper spray pattern. But certain kind of sprinklers will be requiring more pressures like ESFR sprinklers or extended coverage sprinklers, because the coverage of the sprinklers will be higher, and for the ESFR sprinkler, which is the suppression mode sprinkler, which needs more velocity of water to touch down the base of the fire to extinguish. So always it is recommended to use the manufacturer guidelines to see what is the minimum operating pressure required for each sprinklers. But nevertheless, it cannot be less than 7 psi for any sprinklers as mentioned in NFPA 13. The minimum operating pressure mentioned in NFPA 13 is 7 psi and the maximum operating pressure is 175 psi. As I have mentioned earlier, two methodologies, pipe schedule and hydraulically calculated method. So what is pipe schedule method? The pipe schedule method is one of the oldest means of determining the pipe sizes of sprinkler system and defining a very broad single water demand for each occupancies, regardless of the area of sprinkler operation, as I have explained before. The concept of using pipe schedule methodology is that you do not have any fire barriers in a building, so the fire originated in one place can spread into another place. So you need to have adequate amount of water to provide the sprinklers in order to control the fire or extinguish the fire. If you look into this table, it is taken from NFPA 13 2019 edition. It says a single figure 500 GPM as a minimum water flow, acceptable flow at the base of riser, 500 GPM to 750 GPM for a light hazard occupancies. And the minimum residual pressure required at the sprinkler is 15 psi. Whereas if you perform an hydraulic calculation using density area chart, the minimum flow rate required for a light hazard occupancy will be 150 GPM. But in the pipe schedule methodology, as I mentioned earlier, it is not considering a single fire area. If a fire happens, it will spread. Whereas in the density area chart, the concept is different. So when you are using a pipe schedule method to determine a water flow requirement for your building, you have to use this table mentioned in NFPA 13 for light hazard and ordinary hazard. Pipe schedule method cannot be used for extra hazard applications. Extra hazard applications, you have to use hydraulically calculated method only using density area chart. So regardless of the building size or regardless of the number of floors you have in the building, you need to have the minimum flow rate mentioned here, which is 500 GPM for light hazard. You cannot reduce less than this. Also, the minimum residual pressure required for the sprinkler in pipe schedule method is 15 psi, whereas we have seen in the previous slides, the minimum pressure mentioned is 0.7 bar. Sorry, 0.7, not 0.7, 0.5 bar, which is 7 psi, which is applicable only for hydraulically calculated system. If you are using for pipe schedule methodology, you have to use 15 psi as a minimum. And there are some restrictions mentioned in the pipe schedule, using the pipe schedules. One of the major restriction is you cannot use the pipe schedule methodology for a building which is bigger than 5,000 feet square. And also they have given a pipe schedule chart. So rather than looking into the hydraulics chart from Hazen-Williams formula or from Hydraulics Institute to determine what is the flow rate, what is the friction, what is the velocity, NFPA 13 given us a simplified table which is also derived from the Hydraulic Institute chart based on Hazen-Williams. So here you can see 2 sprinklers can be fed through 25 mm pipe and 3 sprinklers can be fed through 32 mm pipes and 540 and so on. So if you are designing a sprinkler system based on a pipe schedule methodology, you have to create your design based on the pipe sizes given in this table, which is in accordance with the number of sprinklers you are planning to feed. For ordinary hazard also, there is a separate table given in Nfpa 13, which also determines how much, which also shows us how much sprinklers are required for each sizes of the pipe. So once you have developed the design, the sprinkler layout based on the pipe sizes mentioned here, and directly you have to select the pump for the minimum flow rate what it is mentioned in the previous table. And for the pressure, you have to estimate the static pressure required for the building, as well as friction loss required for the building, and the minimum pressure, minimum residual pressure which is mentioned in the table. That will be your pump head. So you do not need to look into area of sprinkler operation, how much area you are going to protect. It is a straightforward exercise. Whereas if you want to follow the hydraulically calculated method, you need to follow a density area chart. The concept between the density area chart, and which is the hydraulically calculated method, and the room design method is, as I have explained before, room design methodology uses a concept that if a fire is happening at one place and it will ultimately spread to the adjacent space. So that is why higher water demand is mentioned for the light hazard and ordinary hazard in the previous table. Whereas if you are using the density area chart method, which is a hydraulically calculated method, you do not need to consider 500 GPM as a minimum flow required for your building. So let us see these examples here. Let us see one of the example based on this density area chart. If you look into the light hazard line, so these are the 5 types of hazards as you can see. The area of operation which you can design is from 1500 square feet till 3000 square feet. And corresponding water densities we have to taken based on the area of sprinkler operation you are choosing for your design. Assume you have a building of 5000 square feet and you want 2-story building or a 3-story building. You want to design an office building. Office building will come under light hazard occupancy classification. So if you want to design a sprinkler system for an office building, you have to choose the light hazard line. Then you have to choose the area of sprinkler operation and multiply it by the corresponding water density. So in this case, 1500 feet square area of sprinkler operation, the water density required is 0.10 GPM per foot square. So if you multiply this, you need a minimum flow rate of 150 GPM only. Whereas in pipe schedule method, you have to provide 500 GPM. So the same example goes for ordinary hazard also. We have seen just before in this table, the minimum flow rate required at the base of the riser is 850 GPM. Whereas if you design based on ordinary hazard, 1 or 2 group classification, again it is similar to light hazard, selecting the area of operation and multiplying the density at the corresponding line. So if you choose 1500 feet square as an area of sprinkler operation in ordinary hazard group 2 as an example, the water density is given corresponding to 1500 feet square is 0.20 GPM, so which will be 300 GPM as your water demand. So there is a quite lot difference between using pipe schedule methodology and the hydraulically calculated methodology. And if you look at this line, the extra hazard group 1 minimum area of sprinkler operation starts from 2500 square feet, whereas the ordinary and light starts from 1500. Now imagine you have a building with an area less than 2500 square feet, but it is classified as an extra hazard. So how we need to calculate in this scenario? You need to take the actual area of the building and multiply the minimum density mentioned in the, multiply the density of the minimum area of operation to the corresponding hazard. So I have told you it's extra hazard and I have 1000 square feet of a building. So what will be my flow rate? So 1000 is the area of sprinkler operation because my building size is 1000 itself. Then the density I have to choose is 0.30 GPM per foot square, which is the water density required for the minimum area of sprinkler operation corresponds to extra hazard group. So in this case, we need to have 300 GPM of water. There is another methodology called room design method. Room design method will be used when you have a series of rooms in a floor of a building, and these rooms are fire rated for 2 hours. Then the water demand will be chosen based on the most remote and most demanding room in the particular floor. For example, you have a 10 rooms in a particular floor, and all are typical 3 square meter room size, and one of the room is 5 square meter. So you need to calculate what is the water demand required for the 5 square meter room, and you can select the pump accordingly, because fire, as the concept of hydraulic calculation using density area chart, is fire will be happening at one place in a building and it will be confined based on the fire barriers. So the same applies to room design method also. If the walls are fire rated, the fire will not go from the will not pass the area of origin, it will be confined within the space. So if you choose the higher demand, which is the 5 square meter room, so if a fire happens in a 3 square meter room also, the water demand you have selected is more than sufficient. This is one of the concept of using room design methodology. It should be used only if you have a series of rooms with a fire rating provided for all the rooms. If you are not providing fire ratings for any one of the rooms, then the room design methodology cannot be used. Another thing mentioned in Nfpa 13 is reduction and increase in area of operation. As we have seen before in the density area chart, the minimum area of sprinkler operation mentioned for light hazard and ordinary hazard is given as 1500 feet square. If you are using a quick response sprinkler, which is having an RTIA of less than 50 and less, you can reduce the area of sprinkler operation to a certain extent. So for instance, the below picture is extracted from Nfpa 13, which shows how much the percentage reduction is allowed based on the ceiling height if you are using a quick response sprinkler. So if you look at a room height of ceiling height of 10 feet, which is 3 meters, and if you're using a quick response sprinkler, the area of sprinkler operation you can reduce by 40%. So 1500 is your original area of sprinkler operation. So if you reduce to 40%, it will be around 900 square feet. So 900 square feet corresponding to the density of 1500 square feet, which will be 90 GPM only, instead of 150 GPM when you use the values directly from the chart. This will be applicable only if you are using a quick response sprinklers. And sometimes you need to increase the area of operation also. The area of operation needs to increase by 30% if you are using a deluge system or a dry pipe system, because initially the water will be initially there will not be any water available in the piping network. So when there is a detection system activated, the detection system will be triggering the deluge valve to open, and which causes the water to flow into the pipe, which will be a certain delay for the water to move inside. To accommodate the delay, we need to have a higher amount of water to control the fire. That's the reason the 30% increase in density area operation. Thank you.